Well, a very good evening. The topic that we'll be discussing in this part is convolutional neural network architecture. So, in an ANN, we have three different layers: input layer, hidden layer, output layer. The same goes with CNN also. We have all the three different layers: input, hidden, and output layer. But apart from this, two further layers are accompanied in this, that is convolutional layer and pooling layer. Now let us see the architecture of this. So in the beginning we have the input, and input will be in the form of images. So image data is given to the CNN process, then followed by the images. The next part is feature learning. So whatever the features there will be in the image, so that will be analyzed. And how this will be analyzed? This will be analyzed through a stack of convolution and pooling layers. So a number of convolution and pooling operations will be performed in this part. Then the output that is generated by feature learning is in the form of a two-dimensional space. So we need to convert it into one dimension. So we need to flatten it further. So flatten layer will reduce it into one dimension. And after this, we will have a fully connected layer. Now fully connected layer is just like the ordinary ANN, where we have input, hidden, and the output layers. And the output that is generated here is the probabilities. Let's say the probability of first part is 0.82, the second is 0.11, the third is 0.07. So maximum probability is 0.82. So it represents that the image that is originally that was there is of a computer. So this is how the architecture of CNN is there. Now let us find out what is the role of convolution layer. Convolution layer performs operations, and these operations are called as convolutional operations. Now among what these convolution operations are performed? These are performed between input data and mask, also called as filter or kernel. Input data is in the form of the images, so that is in the form of pixels. Now what is done in this convolution operations? First of all, we'll do matrix wise multiplication, and then we'll do the sum of products. How come? Let us see this image where we have the original image in the form of source pixel that is there in a particular image. So 3 by 3 grid is taken from the source pixel, and then it is multiplied by a mask, and the output that is generated is 7. Now how we have reached up till here? So mask is multiplied by each individual source pixel. So the first row is picked up from the source pixel, that is 1, 0, 2. It is multiplied by first row of the mask. Similarly, second row is picked up. It is multiplied by second row of the mask. Similarly, third row is picked up. It is multiplied by third row of the mask. Then sum of products is done, and the output that is obtained is 7. The same will apply to all the various pixels that are there in the image. So this is how we'll get the output that is in the form of a feature map. So this is the output, that is the feature map, that is the output of convolutional layer. So it represents all the learned features that are obtained from the image after applying the convolution operation. Then is followed by the convolution layer is the pooling layer. So what pooling layer does is it reduces. What it reduces? It reduces spatial dimensions. What is meant by spatial dimensions? Spatial dimensions means height and width of the image. So what is the charm in reducing the spatial dimensions? The basic purpose of reducing the spatial dimension is the computational complexity is reduced. The size is reduced, so automatically computational complexity will be reduced as the processing is getting reduced here. Now the pooling techniques, this includes maximum pooling and average pooling. These are the two most common pooling techniques that are there. Apart from this also there are a number of other techniques also, like min pooling, mean pooling, probability based pooling, but these two are most common. First is the max pooling. Now what happens in max pooling is we'll select the maximum value in each pooling region. That is, in the first region, if you see in the green part, then the maximum region is 32. So we'll find out the maximum region and we'll replace it in the box. Similarly, for second region, the maximum element is 19. For third region, the maximum element is 20. The fourth region, the maximum element is 27. So a 4 by 4 feature map is replaced to a 2 by 2 grid. So automatically the spatial dimensions are reduced. When the spatial dimensions are reduced, complexity is reduced. So what kind of application do we find it here? We find that sharpness is getting retained. And what are the practical applications where sharpness is getting retained? It can be fingerprint recognition, it can be face recognition, it can be object recognition where sharpness is required. There maximum pooling works. Then is average pooling. Just like we identified the maximum portion from each region, now we'll do the average of the entire region. 32 plus 10 plus 4 plus 14 divided by 4. So the average is 15. For second region, average is 14. For third region, average is 11. For fourth region, the average is 16. So, and such kind of operations are used where we require smoothness, like blurring of the images. You want a certain portion to get blurred. What is blur? Edges are reduced. So when the edges are reduced, so there will be smoothness. So such kind of operations are useful in average pooling where we require smoothness. So the example is blurring. So where is CNN basically used? CNN is used in all the computer vision applications. What applications? Like fingerprint recognition, blurring, image segmentation, image classification. In all these places, we'll be using CNN architecture. So if you got some knowledge from this video, then do like, comment, share and subscribe, and thanks for watching.